All right, so this question gives us mass and velocity, as well as force, and it's asking us to solve for time for part one. Now, to solve for time, we need to figure out a relationship between mass, velocity, and force. And so in this case, momentum and impulse should hopefully come to mind. We know the equation for impulse for J, that is mass times a change in velocity. We know the mass, we know the initial and the final velocity. It says it slows down to a stop. So we can figure out the change in velocity would be, in my case, 18.2. So both of those variables are known. Now the other equation we have for impulse is force times time. And so we can see really quickly that they do give us the force. The only variable that we don't know is the variable that we're looking for, time. So in this case, time would be equal to mass times a change in velocity divided by the force. If we go ahead and plug in our numbers, this is going to be 2,000 times 18.2 divided by the force is 8,310. So our time is going to be equal to 4.380. And that's in seconds. Now for part two is asking about the displacement. So hopefully in this case you would think, okay, well what does mass, velocity, force, and displacement, what do those have in common with each other? And so that is energy. Those variables are tied together by energy. So the change in energy is equal to the work that's done on the car. Now, if it's coming to a stop, the energy that's changing is its kinetic energy. So the change in kinetic energy is equal to the work. Let's take this a step further. I know the equation for kinetic energy is half the mass times the change in velocity squared. That's equal to force times distance. And what we're looking for, what we're trying to find is the distance. So if we move this around and solve for D, then what we'll end up with is mass times change in velocity squared over twice the force. Plugging in our numbers here, we're going to get 2,000 again, this time multiplied by 18.2 squared, and then divide that by twice the force. So in parentheses, 2 times 8310. And that's going to give us a displacement equal to 39.86 meters. There you go.